Hey, welcome to the Explainer. You ever have one of those brilliant ideas that, feels more like a fuzzy sketch than a solid plan? Well, today we're diving deep into exactly that. How you can take a really fascinating but kind of vague concept and forge it into a system that's structured and, most importantly, testable. So let's jump right in.
So, here's the big question, right? How do you actually turn a vague idea into a solid system? How do you create what's basically an architect's blueprint for a concept? We're going to walk through a real-world example of this exact process and watch as a conceptual puzzle gets transformed into a coherent framework.
Okay, so the puzzle we're going to tackle is this really interesting concept called symbolic numerology. Now, the basic idea is that different numbers have these unique symbolic roles. But the problem is, in its original form, it's kind of like a jigsaw puzzle with a bunch of missing pieces. It doesn't have clear, universal rules. Honestly, it's more of an art than a science.
To get a handle on this puzzle, we first need to meet the two main teams of numbers here. On one side, you've got what the source calls the mukataat numbers. Let's just call them the M numbers to keep it simple. That's 2, 3, and 7. Think of them as the primary, foundational players. And on the other team, you've got the non-M numbers. That's all the rest. And their job is to act like bridges and connectors between the others.
And this is really the heart of the problem. When you don't have formal rules, it's all just guesswork. My interpretation could be totally different from yours. You can't really test it, you can't build on it, and that's exactly why we need that blueprint, to give this really cool idea a solid foundation to stand on.
All right, so let's start building. The first tool we're going to add to our architect's blueprint is something called the Methonic operator. The whole point of this tool is to create one single, consistent rule for how numbers can transition from one state to another. No more guessing.
And you know what? The rule they came up with is so simple, it's beautiful. The Methonic operator, or M of n, is just 10 plus n. That's it. So M of 3 becomes 13. M of 7 becomes 17. All of a sudden, we have this crystal clear, universal formula that works the same way for every single digit number. The guesswork is officially gone.
Okay, so let's put this new rule to the test. Let's just follow the steps here. We'll start with our M number, 3. Step 1, apply the operator, M of 3, which gets us to 13. Then the framework has this doubling step, so 13 plus 13 gives us 26. And for the final step, we sum the digits. 2 plus 6 equals 8. And boom! Just like that, we've followed a clear, repeatable process to turn an M number into a non-M number.
And that is the real power of our very first tool. This formal process creates a predictable, totally analyzable pathway between our two categories of numbers. We just saw it happen. We watched one type of number systematically turn into another. We've created a rule, and that changes everything.
Okay, on to our second blueprint tool. This one builds directly on what we just did. Up until now, those multi-digit numbers like 13 and 26 were just kind of temporary steps along the way. Well, this next tool gives every single number, no matter how big, a clear identity inside the system.
The rule is actually pretty straightforward. Any multi-digit number belongs to the same category as the sum of its digits. So for example, take the number 34. It's not just 34 anymore. You add its digits, 3 plus 4, and you get 7. Since 7 is one of our M numbers, we now say that 34 is mukataat leaning. Same thing for 13. 1 plus 3 is 4, so 13 becomes non-mukataat leaning. See? Every number now has a team.
So you might be asking, why does this even matter? Well, it reveals this hidden layer of connections that we couldn't see before. Look at the cycle from the source material. 7 becomes 17, which then becomes 34. With our new index, we can trace the family line. We start with 7, an M number, and the cycle ends with 34, which, as we just saw, is M leaning, because 3 plus 4 is 7. This shows a consistent categorical theme running through the whole process. We're starting to see the hidden patterns.
Okay, so we've defined our special operator, and we've given every number an identity. Now it's time for the final and maybe most powerful tool in our blueprint, a way to see the entire system all at once. This is where we map out every single possible interaction to get the full picture.
And the tool we use for this is called the interaction matrix. I want you to just picture a simple grid, like a multiplication table from grade school. But instead, this grid systematically shows us exactly what happens when any two single-digit numbers are added or multiplied. It is basically a complete map of the framework's internal DNA.
So let's check out a little piece of the addition matrix. If you add an M number like 2 to another M number like 3, you get 5, which is a non-M number. Okay, interesting. But look what happens when you add an M number, 3, to a non-M number, 4. You get 7, which is an M number. The matrix lets us see these flips between categories instantly.
Now, the multiplication matrix is where things get really cool. Check this out. When you multiply two M numbers, like 3 and 7, you get 21. Now, remember our index rule? We sum the digits. 2 plus 1 equals 3. It brings us right back home to an M number. This is huge. It shows this powerful self-reinforcing property inside the system, and it's exposing this deep underlying structure that was invisible before.
And that is the ultimate payoff, right there. What started out as just an intuitive claim about primary numbers and bridge numbers now has hard, visual data to back it up. These matrices give us what the source calls empirical evidence for the whole hierarchy. We've actually done it. We have turned an abstract idea into a system we can test and analyze.
So let's zoom out for a second. By using these three pretty simple but really powerful tools, a clear operator, a classification index, and an interaction map, we've actually accomplished our goal. We have our finished blueprint.
And this is the transformation. This is what it's all about. We started with a conceptual puzzle. It was fascinating, for sure, but it was vague, inconsistent, and really just based on intuition. And where did we end up? With a formalized system. One that's structured, consistent, and built on a solid foundation of clear, testable rules. That's the power of building a blueprint for an idea.
And that really just leaves us with one final thought. This whole process, it isn't just about numbers. It's a method. It's a way of giving structure to thought itself. And it really makes you wonder, doesn't it? What other hidden patterns out there, in science and art, maybe even in our own thinking, are just sitting there, waiting for someone to build the right blueprint to discover them?